Right? So here's a case where we have, when you look at it, we have a reflection, we have a vertical shift, we have a flattening. So all three of those parts are elements of this. Okay, so let's take a look at what our general tendency looks like. Okay, if we start with a y equals x graph. Okay, the first thing is we have this vertical shift. So the plus 3 lies outside. So we're going to take this graph and we're going to move it up 1, 2, 3. So now we're basically looking at this function. Okay, so again, if we were looking at it in just pieces, this would be y is equal to x plus 3. Now, there's other things done to this, so we're not done with our graph yet. Okay, let's take a look at the next thing. The next thing is our negative. Okay, when we apply this negative, we have reflection. Now, this negative is happening right to our function right here on the outside of it. Okay, so we're going to reflect across the x-axis. The x-axis is this horizontal. And again, it's always going to be based on this given point. So we moved our kind of critical point right up to here. So we're going to reflect our graph along that critical point. So right now, we get this reflection of the red graph to form this blue graph. So now this is the graph negative x plus 3. Okay, and then the final step for this is we're going to apply the 2/3. Is the 2/3 going to shrink it or stretch it? So again, you look at just the absolute value of this. So the absolute value of negative 2/3, whatever the multiplier is that a value less than 1 or greater than 1? Less than. So you're going to have a flattened graph. So we're now going to take our blue graph here and we're going to flatten it. So to flatten it means it's going to be a little bit flatter this way. Okay, and so this is what our final graph looks like. So this is the graph of y equals negative 2/3 x plus 3. So let's test this and see how consistent this is with kind of what we were expecting based on the slope-intercept form. Okay, so the way that you guys have been taught, and rightfully so, because it's easier to sketch the graph of a linear equation, is we just, again, let's talk through that. Sketch the graph of linear equation. All right, so if it's given in the slope-intercept form, y equals mx plus b is the easiest way to do it. Plot the y-intercept. Okay, so if we were doing that, we'd plot negative 3. So we can come up here at 1, 2, 3. So here's our y-intercept. And then the second step is to use slope to find a second point. So now we can use our slope, which is down 2, 1, 2, over 3, 1, 2, 3. And then we can connect that to form our line. Now, that's much easier, right? Again, the whole reason I'm going through the steps of this transformation is all those transformation rules apply to any type of equation you might be exposed to. So this year it would be quadratic equations, absolute values, possibly square roots and cube roots. Next year it'll be some rational forms, and just any functions that you are exposed to, these transformation rules apply. Okay. All right, let's take a look at another form or another way that you might be asked to manipulate and sketch graphs of different equations. Okay, so what if I gave you an equation in the following form? Right, this is what's called standard form. Okay, standard form means that you have your equation written with no fractions, and it's written with the x and y terms together on one side and a constant on the other. And it's also sometimes referred to as the intercept form, because this is the way that you probably first learn to graph, because it's real convenient when you have this standard form just to plot values, find what your value of x and y are when the other one is 0. Okay, so one way that you can do this is to find the intercepts. Okay, so if we wanted to find the y-intercept, that means what's the value of y when x is 0? So if x was a 0 here, meaning that basically this term would be disregarded, what would be the value of y? Y would have to be 2. Okay, so 0, 2 is one set of points. And then to find the y-intercept, we plug in a 0 for the y, which again eliminates this term. So what would be the corresponding value of x? 3. And so the easiest way to find the x and y intercepts, and then just connect them to form a line. Okay, so if we were sketching this, we have 0, 2, we have 1, 2, 3, 0. Okay, so this would be the easiest way. So this is called intercept form, or standard form. Okay, so if you're given a graph in this form, in the standard form, just use intercepts. It's the easiest way to sketch the graph. And now you could also convert into slope-intercept form. Okay, so if you convert into slope-intercept form, what you would basically do is solve for y. So if we took this equation right here and we solve for y, we get 3y is equal to negative 2x plus 6. Divide each term by 3. Y is equal to negative 2/3 x plus 2. And we could sketch it by our intercepts. So we plot 1, 2. Here's our y-intercept. Down 2 over 1, 2, 3. Sketch our graph. And we wind up with the exact same thing. Okay, and we could also use the transformation rules. So we take our initial graph, we move it up 2, so it shifts up 2. We reflect it, so it gets reflected down. And then it becomes a vertical shrink, or I'm sorry, a shrink. So we flatten it out and it becomes this black line as well.